All right, and we want to do a thermal analysis. So we're going to come down here and we look at just steady state thermal. So I'm going to click and drag it up here. Looks good there. So come in here and we're going to update the data so we can get the materials we want. We actually aren't going to use structural steel, but I'll just leave it there because that's not going to hurt anything. Come up here to engineering data sources. Click on that to get these. By the way, if for some reason these don't show up here, engineering data sources, outline of favorites, all these, just come over here to view and you can turn these on and off and get access to them. All right, so that way you can see the different windows here. But we're going to come in here and look at different materials here. To go to the general materials first. So we get here, we got aluminum, so we'll add that. And do we have glass? Oh, concrete, let's add that. And glass, we need to get, we'll go down here to thermal materials. And see if we can find glass in here. There's glass. So add that. So now if I go back and turn off engineering data sources, I'm going to have concrete, glass, and aluminum alloy in the data that I can use in my program. Alright, that looks good. So I'll close out of that. And go ahead and let's bring in the geometry. So right click on that. Import geometry. So I could get the SOLIDWORKS version, but I want the step file. So I have the Windows assembly there. And now I can open up my model. Alright, so I got everything showing here. So let's come in here and get the geometry, apply the appropriate materials. So we'll do the aluminum frame. And change that to aluminum. And do the other aluminum frame. So get that to aluminum. And we'll do glass. And get our glass there, concrete base. And call that concrete. Alright, looks good there. By the way, connections. So since this is an assembly, we have different connections between the pieces. We just want all these contacts. They should all be bonded. So if we click on the contact region, it'll show us where they're actually between the two bodies. So the aluminum frame and the glass. We should see that they're all bonded. So if we'll go to the other contact regions, this one's bonded, and then the last one, they're all bonded. So we want the thermal transfer to go right through each of those material. We're not going to be concerned about any thermal effects between the connections. Go down here and mesh. We could do that. Update. All right, so that's very coarse. So we'll come down here. We'll update that to fine and see what we get there. All right. So then we got 1 element thick there in the glass, and still pretty coarse elsewhere, but should be good enough for what we're dealing with right now. Let's apply the boundary conditions here. So we got convection on both sides. So let's get all the stuff on the inside of our space. I'm going to hold down Control now to get additional surfaces. Alright, so I got my surface. I can click Apply. And BTUs per second, let's see here, BTUs per second inch squared. This one's 68 degrees Fahrenheit. But BTUs per second inch squared Fahrenheit, and ours was in feet squared hours. So let's get over to feet. So we'll change our units to the feet, US customary. And going back to our model, we were in BTUs per hour feet squared. So we got everything else except for the hour. So 1.46 divided by 3600 will get us to what we want there. So let's put, it doesn't do the math in ANSYS. So let's do that via calculator. So 1.46 divided by 3600. And we can just go ahead and edit copy and paste it right in there. All right, so we got everything we need there for that boundary condition. So now let's go to the other one. This one I'm going to click on the surfaces first. So come up here and click at the top surface. That looks good. So we'll do convection on that one. So I got all the surfaces there. And this is outside, so we're at 10 degrees Fahrenheit. And for that one, we're at, we go back to our model, we're at 6 BTUs per hour, feet squared, degree Fahrenheit. So we'll take that 6 and divide it by 3,600. And copy and paste that into our convection coefficient. And I think that's about it. We can go ahead and solve. So we'll solve the model. I'll just look at the side temperature profiles here. And we got to make sure we have a temperature profile to see. And you can see there, so we got this temperature distribution that's happening through the concrete because it has relatively low thermal conductivity. Actually, let's go back and look at those thermal conductivities. So come back here to engineering data. You can see down here for the aluminum alloy, it's tabular. So if you come up here to the table, we see it's in the greater than 100, close to 150, probably in the range, yeah, that we're looking at here. For concrete, it's much lower, 0.72, and glass is relatively low too at 1.4. All right, so you see that large thermal gradient in the concrete because it's so thick. All right, and the conduction is very low as compared to the aluminum, all right, which it goes through very quickly. All right. But the one thing I want to update here is if we look at the mesh again, look what we have here across the glass. We only have one element across the thickness of the glass. Now there's obviously 1, 2, 3, 7 across that way, but we're really interested in this distance here. And really one element wouldn't cut it in any type of model that you would want to analyze. You want to have at least 2 at the extreme minimum, more like 3 elements at the minimum. So we want to get that, and we just want to get that in the glass. The other aluminum and concrete are okay. So to do that just for the glass, we're going to come up here to Mesh Control, click on Sizing, and we'll just select the whole body. So right now we were selecting faces because this is the button down. So we're going to change it to the body element. So we can click it for the glass there and apply. So this is going to be applied to the whole body of the glass. And we want to do it by element size. You want to say what that size is. So let's go back and make sure we're looking at right along the edge. And if we zoom in here, try to get a sense of scale, what's going on here. All right, the thickness of this glass from the model is 0.25 inches. So if we want to get 3 elements across there, we need to take 0.25 divided by 3. So 0.0833. So let's go ahead and put that in there. So our element size is 0.0833. Oop, this is in feet, so I need to divide that. So I had 0.25 inches divided by 3 divided by 12. So let's copy that. All right, so that should give me an element size here. So let's see what happens here now if we go ahead and update. So we get 3 elements across, and obviously several elements this way. So now we have the elements we want. So now let's see if we can even, if this model would run, because we have a restriction, at least with this license, on the number of nodes. And it looks like we're going to be over it. So if the nodes or the elements is over 256,000, it won't run. Actually, just let me show you what happens. So if you run into it. I'm going to go ahead and solve here. So it doesn't get into solution. You see your product license has numerical problem size limits. You've exceeded these limits. So that's just, again, we're over 256 nodes. So what we'll do to get down to something that can work is we'll go back to our SOLIDWORKS model, and we'll make this thing a little bit thinner.